Right, back on it with part 3. Multiplying and dividing fractions. Janine is saving to buy a handbag which costs £15. After 1 week, she has saved 1/3 of the amount she needs. How much is this? This question says to me, screams to me, draw a bar model. So we'll draw a bar. The whole handbag costs £15. So that's the whole bar. Janine saved 1/3. So if we split this bar into thirds, this amount here is the amount saved. So this amount here is the amount she needs, because it's asking us how much she needs. It's telling us she saved 1/3. So if we've got thirds, we're going to do 15 divided by 3, which you can go up in your 3 times table, or you can do bus stop division, your short division method, or maybe if you've been practicing, especially on the times table app, the Pixel times table app, you can do that quickly in your head. 15 divided by 3 is 5. That means each of these thirds is 5. If you're looking at me blankly when I say the Pixel timetable app, speak to your maths teacher next lesson and ask them. Right, because I've labelled this up, I'm not going to make a mistake. Although the question has made a mistake, so I will make sure this is changed for next half term, because it says, oh no, I've misread the question. Do you know what? I'm glad I double checked. So, after 1 week, she has saved 1/3 of the amount she needs. So she saved £5. How much is this? I was going to go about it the wrong way and find out how much she needs until I looked back and reread the question. So, after 1 week, she saved 1/3. 1/3 is £5. So how much is this? She saved £5. I think the only reason I realised my mistake is because I tried to highlight the key bits and I'd read that part there. So that says to me, even for a teacher, highlighting the keywords or underlining them stops those silly mistakes that if I'd got this the second time, I'd have kicked myself if I'd got that wrong. Right, part B. A train runs late, so it's late 2/5 of the journey it takes. So we know we're going to be drawing a bar model 5 squares long this time. I know you don't have squares in your test, so it can't be as perfectly accurate, but 1, 2, 3, 4 lines means 5 squares. If Jason takes the train 20 times, how many times will he expect it to be late? Well, if that whole thing then is 20, and you should be copying down everything I'm saying, which includes the bar models then, Josh, doesn't it? So, the technique here is always find one part, find the unit fraction. So 1/5 is going to be 20 divided by 1, 2, 3, 4, 5. So 20 divided by 5 equals 4. So that means each fifth is 4. He's late 2/5. So how many times will we expect it to be late? Well, 2/5 will be 2 lots of 4, which is 8. So Jason will be late 8 times. So I've divided it into 5 equal parts, and then I want 2 of them. I want those 2. Now, when we're multiplying fractions, we've drawn some bar models of this, and we know that the times means, another way of writing that could be of, so don't be surprised if you say 2/5 of 1/3, they're interchangeable, they mean the same thing, so that's good to know, because a post-test could have 2/5 of 1/3. We also know that multiplication is commutative, so we can write it in either order. And for multiplication, this will leave us with 2 times 1 is 2, 5 times 3 is 15. The bar model that shows why that works. The bar model that shows why that works. If I want 2/5 of 1/3, I'm going to split this bar into thirds. So each of those parts is a third. So that is 1/3. And I want 2/5 of that third. So if I split this third into fifths, I only want those 2 bits. Now, because I've split that third into fifths, I'm going to have to split the other 2/3 into fifths as well, which means that I will end up with 2 parts out of 15 in total. So that's where the 2 out of 15 comes. Five halves times 1/4. 5 halves of 1/4. So we'll draw our bar model again. And this time we're splitting it into quarters. So to quarter, 4 equal parts, or half it and half it again. And if that's 1/4, I want 5 halves of that quarter. So if I split that quarter into halves, I'm going to have to split the other quarters into halves. And if I want 5 halves of that quarter, I'm going to want 1, 2, 3, 4, 5, which is 5 parts out of 8 parts in total. So I drew quarters. I then split each quarter into halves, and I wanted 5 of those halves. Now though, the bar is split into 8 parts, and I want 5 of those 8s. Right, 6 divided by a quarter. If you speak to somebody younger than you, with less maths experience, they might think that every time you divide, a number goes down. But we've started to recognise that, and my class have done a lot of this today, that we know, using reciprocals, that 6 divided by a quarter is exactly the same as 6, do the inverse of divide, which is times, and do the reciprocal of 1/4, which is 4. So once you know about reciprocals, you can change divided by a quarter to times by 4, and 6 fours is very easy. 6 times 4, or 4 times 6, which gets you 24. So what we've done there is, I've not finished writing notes, so I'm not sure why you're turning your page. We've done the inverse of that, and we've done the reciprocal of that. So the inverse of divide is times, the reciprocal of 1/4 is 4. Okay. So 6 times 4 then becomes 24. Okay, on to the second part of part 3, and then we just got part 4 to do. Should be well within time. Find the answers to the following. Now, if we're happy with reciprocals, and this is getting a step harder, we can change this to the inverse. So we've got 4/5 times by, and if we do the reciprocal of 8/15, it gets us 15/8. I appreciate some people remember that you've changed that and flipped that, but I really don't like hearing that, because you need to understand why you've done it. You've done the inverse of that, which allows you to the reciprocal of that, and in maths lessons, I know my class have today, we've proved why that works. Right, if you're wanting to do 4/5 of 15/8, you would have to draw a bar model of 15/8. Now, what we want to get to the point of is, we don't need the bar models anymore, because bar models are a tool to help us understand. If I just flick back a page, and you don't have to, what you'll notice is when we multiplied the fractions, we showed why it worked with our bar models, but what the calculations were the numerators times together and the denominators times together. So now when we've seen it works for simpler ones as a model answer, we can put that into practice for harder ones. So this means the same as 4 lots of 15 over, sorry, get that on the full screen, 4 lots of 15 over 5 lots of 8. 4 lots of 15 you can do in your head. You could do 4 lots of 10 is 40 and 4 lots of 5 is 20 and add them together. And then 5 eighths is 40. It doesn't ask you to simplify, but the mathematicians in us look at an improper fraction and look at it and think, firstly, I could divide by 10, which gets 6 over 4. Secondly, I could half them both to get 3 over 2. And then finally, if I've got 3 halves looks like this. 2 halves there, and 1 more half, which is 1 whole 1 and 1 half. On this question, you'd get the full marks for 60 over 40, but the mathematicians amongst us should be really wanting to try and simplify where possible and leave a mixed number where possible, unless asked. Right, getting slightly harder again. The only difference with these ones and the ones on the previous page is they're mixed numbers. So the first thing we're going to do is change them from mixed numbers to improper fractions. Again, on the previous page we've drawn bar models of how to do that, but then we've also talked about if it's in thirds, 2 whole ones of thirds is 6 thirds, plus 2 more gets us 8 thirds, and 3 whole ones split into quarters is 3 fours, which is 12, plus 1 more quarter gives us 13 quarters. So that means the same as 8 times 13 over 3 times 4. And again, I know you can do that in your head even though you don't practice your 13 times table. Because you could do 8 tens are 80, 8 threes are 24, so 80 plus 24 is 104, and you can all do those calculations. 3 fours you should definitely be able to do is 12. I can definitely do some simplifying here. As an easiest thing, I can see they're both even numbers. Even numbers are always divisible by 2. So let's half them both. Half of 104 is 52. Half of 12 is 6.